Okay. Good morning, everybody. Simba, I will let you take it away.
Awesome. Thanks, Mary. Hey, everyone. Today we are going to be talking about MLOps in 2024. Um, some rules of presentation, how this will work. At any point in time, feel free to ask any questions you want. If you're in LinkedIn or Twitter, you can just ask there. Maria will be looking there. And then if you're on the Zoom call or the Zoom webinar, you can throw in the Q&A and we'll make sure to answer them. I have kind of some natural breaks throughout the presentation where I'll be able to answer. Today, we're going to be talking about MLOps best practices in 2024. Obviously, 2024 just started. So a lot of what we're actually going to do is first zoom back to where MLOps started and where we're going. We're going to define MLOps. We're going to get really technical. We're going to break down what makes up an MLOps platform, from the data to the training to deployment to monitoring. Then after we get to the technical components, which I think is what a lot of people focus on, we'll zoom out a bit and talk about how to measure MLOps platform success. And we'll end with where I think and where at Feature Form we think MLOps is going in 2024. We'll share a lot about LLMs, LLM ops, and our thoughts there, just because that's obviously a huge change that's happening. Great. Let's start by talking about what's happened. Where's MLOps come and gone? So for those of you who have been doing MLOps for a while, you may kind of resonate with this. MLOps as a term really started to gain traction like late 2020, 2021, where it went from being something that everyone did. Like if you had machine learning models in production, you did MLOps. We just didn't call it MLOps. The category, the best practices, the definitions really started to appear in 2021, in 2020 and 2021. And at that point, it was still new. There's a lot of new stuff happening. There's a lot of excitement. There was a lot of kind of growth, a lot of learning, a lot of sharing of learning. In 2022, there was this massive explosion of startups. It felt like there was a billion MLOps companies. They were all kind of sort of doing similar things. There's a lot of overlap. A lot of the products weren't built out yet. And there was just huge growth in MLOps teams as the category kind of started to exist. I think in 2023, we had the market shifted, a lot of things changed, and I think we had a really necessary kind of, uh, let's say, reality check on MLOps, where it's like, hey, there's a ton of value here, but we, maybe overshot, over-indexed, and there was just MLOps teams being built, products being built, tools being bought that didn't really make sense for where companies were at. And what I'm really excited about, what I'm seeing now, is just kind of another curve up. I think that MLOps, now that a lot of the hype has kind of been sucked out, what's left is the real value creation. And I think that's what we'll see in 2024 is that MLOps will no longer be like the coolest category in the world, but it will be driving tons and tons of real value. And there'll be tons of awesome things built here. So I'm personally really excited for 2024. It's stabilizing. Best practices are forming, and ROI is important now. Like I think, everyone talked about ROI in 2021, 22. This is just like an MLOps thing. I think just ROI was almost forgotten in an environment where money was free. And now that markets are shifting, we are seeing a focus on fundamentals. And I think that's good for the market as a whole and for the category as a whole, because it lets us actually focus on what's really working and get better at that. And it lets us really quickly cut away hype and craft and get to real value. So let's dive into MLOps. I want to start by first, I mean, this is going to be super review, but I like to start here with the simplest model. Machine learning model takes features, which are just data inputs, and make predictions. There's also this concept of labels. which are used for training. This is like the simplest model ever. And when you learn machine learning, like when you take the Andrewing Coursera course or whatever, this is everything looks like this. It's nice, it's pretty, it's perfect. But anyone who's working in production now, anyone who's done machine learning in the real world knows that it looks much more like this. It's really messy. There's just models everywhere, lots of data pipelines, notebooks, scripts that you have to run in specific orders, features that people don't remember how they're built. You have training sets that are just kind of impossible to recreate. This is kind of, I would say, the more common state of machine learning at most companies that I talk to and see. And that's why MLOps exists. Um, MLOps is it's a set of tools and practices to automate and streamline the ML model lifecycle from ideation to production. This is, I think, the cleanest definition I have of MLOps. Now, I think there's something doing a lot of heavy lifting here, which is ML model lifecycle. What does that mean? From ideation to production, like just what do those parts mean? I break down the ML model lifecycle into four parts. At the top of this, there's an arrow. I don't really think that that arrow is like one directional. Oftentimes we jump back and forth between these different stages, but I think it's fair to cut the stages into these four parts. One is just data, working with your data, understanding your data, building your features, serving them for training and production is kind of this whole stage just centered around data. Next, there's a stage centered around training, which is trying different models, hyperparameters, actually training the model itself, etc. Deployment and serving, taking your models into production, and the monitoring and evaluation, which is making sure those models are behaving correctly and you're understanding what they're doing while they're in production. So these are the four stages. An idea we came up with a feature form is creating a second level of abstraction, another dimension, where we go all the way from hardware up to platform. They layer on top of each other. When I think of MLOps platforms, there are layers, right? Like the lowest layers, it might be your EC2 instances. Your highest layer is kind of the framework and APIs that your data scientists actually use, and there's stuff in the middle. A big part of today's presentation is going to be me breaking this down, helping you see like what I've seen come up as the core categories of MLOps, why they're the core categories of MLOps, how to think about the problems they solve, which will allow you to pick and choose where to invest your time and effort. We can actually put these things kind of perpendicular to each other and build a graph, an axis or two axes. And then we can layer on all the pieces that I think make up an MLOps platform. Again, from the hardware to the compute up to the platform. On the bottom, we have the different stages from the data all the way to monitoring and evaluation. I'll start with layer 0 and 1, just because we won't really talk about them much. So layer 0 and 1 kind of cut across all the different parts of the ML lifecycle, from the data piece all the way to serving piece. Hardware could be things like EC2 instances. If you're on AWS, it could be on premise. It could be just with GPUs, like it's just where you're running. The compute framework, it's typically the generic framework of compute. Like examples here include Kubernetes. If you're using any serverless frameworks like Modal or Banana, they fit in layer 1. Ray kind of fits in layer 1. So the Spark, not Spark itself, but you could kind of argue that parts of it kind of fit in layer 1. So these are kind of the first two layers. The next two, I think, are the most important for the sake of this conversation. The services layer, I like to call it the engine layer, and then the workflow layer. This is where most MLOps tools fit in these two layers, because these are the components that I personally think are the core basis of MLOps tools. Now, I break MLOps, so there's the life cycle, and then there's these two stages. right? There's the engine and the workflow, which I think is a take that I have that I've just seen work. When I've seen MLOps services work, they're broken down in this way. Because I think that MLOps problems fall into two categories. There's workflow problems, which are about scaling people, like how do we collaborate? How do each individual just work? What's the workflow look like? And there's engine problems, which are much more like technical, like in the sense of it's how do I scale this? How do I handle this much data? How do I serve with this much latency, et cetera? So there are workflow problems and there are engine problems. And I think that if you build things right, you should separate the concerns. And I think that there are different tools for those different problems. I think that it's a mistake to try to solve both problems with the same tool. So I'm going to go for each of these stages from the data to the model all the way to evaluation and explain all the different components of an MLOps platform. So first, let's start with the data. I have a little point of like the feature orchestration and management. That's where FeatureForm lives. So this is the part that we specifically at FeatureForm do. FeatureForm is we call it a virtual feature store because it sits on the workflow layer and works with the underlying data engines to kind of provide that feature workflow. At the data stage, there's the engine problem and the workflow problem, like I said. The engine problem is how do we serve data in under X milliseconds? Dealing with streaming data, processing X petabytes of data. Those would fall in that layer two. Solutions there are like Spark, Redis, etc. Then there's the workflow problem. These are the problems that FeatureForm solves. Versioning, analysis, being able to look at different data sets, understanding what they are, the statistical properties, the distributions of them, pushing feature pipelines into production. So you might have a feature pipeline in your notebook. How do I get that into production? Monitoring it, getting lineage, being able to share, reuse, collaborate, search different features that have been created, understanding what they are, building off of them, and then governance, which may or may not be a problem for you. So this is how I think of the data stage of MLOps. These are the kind of two problems to solve. So this makes up the data part of the ML platform. And I think I'll go through all the different pieces, but I really want to highlight that it's not you don't need to build all of this stuff at once. I'm going to break all these things down, help you see the problems that they each solve. And then the ones that resonate with you are probably the ones where you'll want to focus and fix first. In practice, you kind of want to build up to solving the whole problem. You don't really need to do it all at once. So next, we have model experimentation and training. Again, two parts, workflow and engine. The engine problem could be things like distributed training, grid search, and hyperparameter optimization. So that's like literally the thing that is training your model. Then there's the workflow problem. Experiment tracking, model artifact tracking, comparing, contrasting. This is where tools like MLflow live at the workflow layer. Like MLflow isn't the engine training your model, but it's doing and solving the workflow part of that. Then there's deployment. On the engine side, you might be worried about scalability, uptime, and latency. On the workflow side, you're worried about A/B testing, upgrading, downgrading, canary deployments, what API we serve and retrieve from. Is it gRPC? Is it CSV? That kind of provides the workflow layer of deployment. And then finally, we have monitoring and evaluation. Similarly, there's the engine, which is like storing your logs, storing having the compute to be able to analyze those logs of like what the model did at different times. The workflow is explainability, alerting, visualizing how different things that the model is doing. I like to think of the workflow layer as painting a picture, which is I can give you a number, right? Like our model is 93% accurate. It's not really useful. It doesn't really explain enough. I think painting a picture is understanding, okay, like where do we do well? Where do we do badly? What parts of things do we do badly? what does 93, like really breaking down what is the model doing and explaining how it's behaving and where and how you can make it better. That's the evaluation piece. Like just having a 93%, playing around with your hyperparameters to get 94%. It's nice if, maybe if you're in academia and you're trying to beat a benchmark, that might be enough. But I think in production settings, it's not as important to have the highest accuracy number. It's much more important to deliver value for whatever that model is doing. So this all comes together into our MLOps platform. Um, there's the layer hardware, compute, the engine from the kind of data transformation storage to training to the monitoring log store, and then the workflow layer. The workflow layer, I think, is the core MLOps pieces. How do we define features? How do we manage them? How do we define experiments? How do we manage them? How do we define our deployments? And how do we evaluate how our deployments are doing? Now, one problem I've seen with MLOps, you can probably name and think of different vendors across these different categories. Like in the feature side, you can think of feature form. On the experiment side, maybe like MLflow. Orchestration management could be a variety of different companies, depending on, like it could be SageMaker. Evaluation, it could be Aporia, YLabs, evidently, etc. It's kind of staccato in the sense of like it's almost like there's these different pieces and there's not really a how do they work together to make a platform work well. I think they all need to work together. So I don't there are companies and products that try to do all of this stuff. I think there's just too much to do, and I think it's better to specialize on best in class components for all these things. The companies that I've seen be successful, they don't I've I don't think I can think of a single company that has internally built. That's not true. There's some companies, but very, very few companies that I've seen build MLOps platforms end to end all at once and have it work in that. Almost always, it starts with people solving specific problems. Like, hey, we have this, our data scientists working in ML, we have all these problems around data. Let's work and bring in a feature store or build one or whatever. Let's solve that problem first. Someone else might be solving a deployment problem for a different team. And you kind of get these pieces that come together. Eventually, you want to abstract them together, make them connect, make them understand each other and talk to each other cleanly. And that's what provides the platform layer. I think trying to go top down is the wrong approach. I think it works much better bottoms up. But what is the layer for? What is the platform layer? How's it look? You can think of the engines as tools, the services, the APIs, like Spark. It's not a MLOps subsystem. It's an engine. It's an API. It's a tool. The subsystems, the workflows, are things like feature form and MLflow that sit above the tools and provide a clean way to define, manage, version. It's just like a framework. It's the engine, like this thing, you give it, processes data, this much data at this speed, and then there's the workflow, which is the framework of how you interact with that thing so that you can keep things clean, organized, shareable, reusable, documented, etc. All those subsystems, right? They need to kind of work together cleanly. If you're a data scientist, you don't want to be switching between, 4 or 5 different things, having like 10 tabs open for all your different tools and 10 tabs of documentation for each different tool. This is where I think internal MLOps teams can take open source and start to kind of abstract and unify to make it work correctly for very specific teams, use cases, etc. And that's the unified experience, the platform layer. There are many, many, many tools for these different layers. This is even a little bit out of date nowadays. Like Mosaic ML now is part of Databricks. I try to stick to like mostly open source tools. They're not all open source on here. There are tools like there are things like SageMaker, which have offerings in different parts of these components. There are tools like Databricks has some stuff like that too. This is, I think, the point I want to make sure is kind of taken away is that there are different sets of problems and understanding what the key problems you have. Like when I've seen companies be successful, they're not building an MLOps platform for the sake of building an MLOps platform. They are finding the core problem they have, which is almost always one of the four things on the bottom here: data, experimentation, deployment, and monitoring. Honestly, it's usually one end. Like it's usually either monitoring and evaluation or the data piece. I've seen those two much more than the middle two, but the middle two definitely exists as well. Um, and then building for that and working from the, hey, what's the engine? Is it Spark? Is it Redis? Like, does that solve our problem? And then building a workflow on top of it or bringing one in. Um, that's what I typically see work. As companies mature, I think I see that's when I start seeing them bring on kind of or build top layer four platform things. The other approach, which I'll mention, is going top down, which is like starting with something at the top, like Kubeflow um, or one of the end-to-end platforms, and then kind of building the whole thing at once and going top down. It can work too. I think I found this in general, I find more success on building to solve a problem than trying to build everything and hoping that it solves a problem in the end. I think in practice, you'll end up with wrong abstractions in wrong places if you work that way. Which kind of gets us to our next section, which is okay, like I've given you a million tools, a framework for breaking down the MLOps platform. That's great. I can, you can ask me any question. I'll name drop you six tools that solve whatever specific problem you have or claim to solve the specific problem you have. But I think a mistake, this is kind of why we had that height of hype in 2022, is we were more obsessed with our tools than we were obsessed with the actual problem we solve. I found out with a lot of people I would talk to is, people this at meetups, we would talk more about tools than we would talk about actually making data scientists and ML teams more productive. And I think it's important to start there with our North Star metrics. So I'm going to break down how I think of defining the value and improving the value of an MLOps team. This is obviously much more relevant in 2023, in 2024, in the land of layoffs than it was in 2021 and 2022. I think the first piece, which is really important, which is kind of sort of out of your control to an extent, is ML has to matter to the company. Like ML has to actually drive real value, and that has to be measured and defined by something that really matters to the business. Like if you're Spotify, like machine learning models that directly affect top line, just how much money they make, or bottom line, which is their cost. So like reducing costs. If the ML teams aren't doing that, if the problems we're solving aren't doing that, then MLOps just makes you do nothing faster. You know, it's like if you're digging a hole and I give you the most cutting edge shovel ever, that's great. You'll dig the hole faster. But if we're digging a hole for no reason, it doesn't really matter. It's still a waste. Um, so I think that's the first piece, but I think it's really important. I think it's important for MLOps teams to understand what the actual business value is. It will help scope and optimize where to put our limited resources. Next, there's a layer of MLOps metrics, which uh, it's actually really very similar to DevOps. In fact, like this is a DevOps image that I think a lot of MLOps teams I talk to think about. These are things like deployment frequency, lead time for a change, time to restore, change failure rate. These are the types of metrics that uh, uh, people think about. Making and optimizing these metrics, I think, are it's real in MLOps. Like these are real and important metrics in MLOps. I think it's very similar, except rather than deploying, we're deploying models. Lead time for change. When I have from the point of I have an idea I want to try to I've now tried it, I have a result, and if the result is positive, it's in production. That's lead time for change. time to restore. Something went wrong, something broke. How fast can we fix that? And then change failure rate, which is how often do models I change or update or push to production, um, misbehave. I think in DevOps it's a lot simpler because in ML, one, the models themselves, depending on the model, but a lot of the models are kind of black boxes. They're hard to really deeply understand before you deploy them. You can kind of understand like things like feature importance, but it's not perfect. Um, so there are many more and you're dealing with data, and data changes, data is messy. You might see data you've never seen before. Something might happen which dramatically changes the distributions of the data. Um, those types of things make MLOps even harder and distinct from DevOps. But I do think that the DevOps way of thinking is a good one, and one that should also be taken into account. And I think then there's a third one, which is uh, this is how I like to think. This is kind of similar to the Dora metrics, but this is the way I think about them, which is velocity, throughput, and risk. So velocity is how fast can an individual data scientist or ML engineer move, iterate, try things, deploy things. Throughput is how well can we work together. A lot of ML teams that I've seen, it's like people work like lone wolves, right? Like everyone does their own thing. They're working on their own thing. Collaboration is very much just like water cooler chat. You don't really get much like, hey, here's this, share this, here's this notebook, here's this data set I created. A lot of that stuff is done in very ad hoc ways, like literally sending CSVs over Slack. And then risks. The risks are going to be super dependent on your type of company. If your risk might be, if you're B2C doing a recommender system, the risk of downtime becomes huge because that's driving real revenue. If you're working at a bank or some other financial institution, the biggest risk might be actually more governance risk. If you do something wrong or the model misbehaves in a certain way, the business can be fined. So understanding the risks is important and building the platform that optimizes for velocity and throughput, which means that it makes it so I can, as an individual, work really quickly, share, reuse, versioning, documentation, all that happens automatically. And then risk reduction is just kind of built like there's almost like guardrails built in so that I can't do anything that would really harm the business. Um, all that just happens naturally in such a way where it kind of reduces my cognitive load. Like, uh, really what I want to do is make sure that I'm not having to think of all these things at once, jumping between different tools. Like, it's just taking away from what as a data scientist I'm really good at, which is coming up with ideas, looking at our data, and building better models to solve real problems. So a lot of an MLOps team's job is just to solve the cognitive overload problem, make it really, really easy to work. And I think one way to do that is treating platform like a product. So there are these kinds of metrics of DevOps metrics, which I think a lot of people get focused on. And then there's platform and product metrics, which are different. When you think of product metrics, right? Like product metrics are much more about usage, NPS score, like how much people like using it, than it is about uptime, right? Like Spotify obviously measures their uptime, but any B2C tool is much more focused on things like usage, MAU, DAU, et cetera, than they are over, you know, hyper focusing on latency and uptime. I think to do this, it's important to remember like what MLOps is for. Like MLOps, we're an operations team. We help operationalize machine learning, both the models themselves and also the people who build them. And the people who build them are data scientists and ML engineers. And I come from a software engineering background. So this was a really interesting thing for me to see because it shows that the way I think, the way I was, what I learned generically is going to be very different from how data scientists think and what they learned. And so that's important to understand because that's how you're optimizing your platform, not for someone who thinks like you as a software engineer or even an ML engineer, but someone who thinks like a data scientist, which is very different. So you want to abstract away things that maybe you as a software engineer or ML engineer really understand deeply and are hyper focused on. So to put this all together, all the metrics, I think there's three layers. At the lowest layer, there is the infrastructure metrics, which are things like uptime, latency, throughput. These are very easy to measure. This is typically where you want to start. If you can't serve your predictions fast enough, if you can't serve enough predictions, if your stuff goes down all the time, who cares about the platform metric? It needs to, I mean, an ML platform needs to be able to solve, like to, fit the hard requirements to be useful. If you're building a recommender system that takes 3 seconds to serve a recommendation, who cares about, the platform metrics and delivery metrics? It's just not usable. So that's step one. A layer above, once you have that, right? Like, hey, like our models, our data, we can manage the scale of data we have. It's almost like the engine problem, right? That thing we showed before, the engine. Like, can we do that? That would be layer three. Layer two, I think, is much more focused on risk, like those three metrics I showed of like the velocity, the Dora metrics, like how fast are we delivering things? How fast are we iterating? Are we documenting things? That's kind of more the product metrics, um, or the platform metrics. And then above that, and finally, I think the one that is often forgotten, but often if you have the bottom two, this becomes the most important one, is adoption metrics. It's easy to use. You might have the best, fastest ML platform of all time that hypothetically could lead to, um, the fastest iteration time possible. But if you're, let's say, an analogy would be like, I give you a F1 car with a billion switches and buttons and like super hard to use, but also, the peak of performance. If you're just like a normal driver, like it doesn't matter, it's going to be impossible to use. You're not going to be able to use it the way, it could be used. And I think that's where focusing on the product metrics, is really what's important, which again are just numbers of usage and depth of usage. How often are people using your platform, your MLOps platform? Are they trying to go around it? Do they like not like using it? Um, if they like using it and they use it often, it's also a good signal that the bottom two things are being solved as well. So I think these are the pyramid of metrics. And I think as we jump into 2024 and as we think about, again, like driving real value of MLOps, getting past the hype, getting past the, hey, like I need this tool and this tool, thinking in this way and presenting, not only just thinking this way for yourself, but also being able to present to your leadership, that this is how we're breaking things down. These are our metrics. Is going to be really important. Because MLOps, we've seen it. MLOps can drive huge value for organizations, but you have to come at it, I think, from a metric-based and a value-based point of view. I also think it's important to think about, where you're at too. Like I've talked about the platform. I've shown you that there's a billion tools. I've shown you the data piece. I've shown you all of that. But keep in mind that, um, uh, so keep in mind also that, it's going to depend on your size of company. Like if you're a, ginormous enterprise organization, you're like a huge bank or something. Um, the problems that you care about and the way you need to think is going to be completely different from if you're a startup and you have maybe 5 or 6 data scientists. Um, and I think that like having your user stories down is really important. Like if you're a single data scientist, you might just need versioning, documentation, experiment tracking. Like the things that you have might be less. If you build up to a team, collaboration, sharing and reuse, documentation, discoverability, just understanding what's going on, like moving from a, hey, I'm like one person hacking, trying to get models production to, hey, now we're a team, we need some level of process, to finally we're an organization, We have many different teams. They're working on different tools. They have different people who originally built their platforms. We have governance needs. We have cross-functional workflows. Now legal's involved, maybe marketing's involved. It becomes a whole different problem space. So as you're building, sticking to the main value props, like what are we trying to solve? What are the metrics? Why does it matter to the organization? Two, like to break that down, breaking down each of those pieces is like, hey, what size of company are we? And who's our end users are data scientists? What's the problems they're currently facing? How do we make them better? Starting at the fundamentals, understanding your user story, and then taking that breakdown, the platform breakdown that I've presented that I've seen to kind of be where I think most organizations have come to. So that breakdown I showed is kind of where I see most companies end up. And using that to pick and choose where to optimize your time as an MLOps team to be able to provide and maximize the value that you're giving your organization. That's what I think is going to separate the best MLOps teams from the more mediocre ones. Now, that's kind of I want to also make sure because the other thing that's obviously on a lot of people's mind, especially those who are maybe on working on traditional MLOps, is where's the world going? Like now what? Now there's generative AI, there's LLMs, like there's this whole new type of model. And uh, I want to break down where I think MLOps and LLM ops or whatever you want to call it are going and how to think about them going forward. The short of it is I actually think it doesn't change much. I actually think that the problem space of LLMs and the problem space of ML are extremely similar. And I'll break that down first. So first I want to maybe talk about just was an LLM. Most of us have probably used one by now, but I want to talk about the most basic way people use LLMs. You write a query that maybe you put into a prompt. So for example, your question might be, hey, like write a slide deck about MLOps in 2024. But I might templatize it into a prompt. I might say, think like you are the CEO of Feature Farm. Give me the agenda for a slide deck, whatever. Like you'd prompt it, templatize it into a prompt. You give it to the LM. The LM's going to spit a response. This is zero-shot learning because you didn't really teach it anything. There's no training step. But if you do this, you'll likely get a pretty good response. That's why LLMs are so powerful. Zero-shot learning and prompts are just this new concept that never existed before. When I see a lot of companies that come from ML start using LLMs, they get really focused on fine-tuning because it looks like training. And I actually forgot about the example data I put here. With fine-tuning, it looks like training, right? Like you're taking a model. The fact that it's pre-trained is almost just doesn't matter because really what you're doing is you are giving it examples and you're pretty much giving it features and labels. The features are the prompt, the label is the expected response, and you fine tune based on that. And that gives you a fine tuned LLM, which you then use like you would any other LLM. But in theory, it should provide better results. Finally, and I think this is probably one of the key pieces because it's and I've seen the most success in LLMs come from RAG. RAG is retrieval augmented generation, which is just a really big word. All it really means, or a really big term, that all it really means is, hey, I'm contextualizing my prompt with my own data. So example, if the user asks, if you're a bank and your user asks, how should I be investing? You might retrieve features like their age, how much money they have, how much they're spending. You might retrieve relevant paragraphs from their blog or your blog, or maybe from your maybe you've recorded your financial or your wealth advisors calls and you pull relevant pieces of information from your wealth advisors. You fit that into a prompt. So given the user has these attributes, they're this age, they have this much money, we're spending this much per month. And using this context, which is like, hey, this is what we typically advise uh, people when they say this. Answer this question: how should I be investing? So what RAG is, retrieval augmented generation, is retrieving relevant data, retrieval, augmenting your prompt with that data, and then finally using that to generate a response for your LLM. This is RAG. And RAG and fine tuning, a lot of people kind of try to compare the two. This is what I've seen. Fine tuning is much more about style. What I mean by that is if you want an LLM to speak a certain way, maybe be like less speak in shorter sentences, whatever, fine tuning typically works very well there. RAG is much more about giving it context, giving it data. It's like feeding data. Fine tuning and RAG, they work with different types of data. Fine tuning is more prone to hallucinate because it's still a kind of you're changing a layer of weights. Where RAG, you're actually giving it like context, which means that it's less likely to hallucinate. And then the other thing which is important is that fine tuning is pretty simple and RAG is quite complex. I'll add that you don't need to just do one or the other. Like you can use RAG with a fine-tuned LLM. They're not separate things. I think in practice, if your goal is to provide relevant data so that your LLM kind of behaves according to some guidelines or according to your data and like is more specialized, RAG typically works better. If you want to speak a certain way or you wanted to respond in a certain way, then it's much more focused on fine tuning. And you can use both, like I said. Okay. And then there's this idea of a vector DB that comes up with LLMs. I'll give you just a quick idea. All a vector DB does in the context of LLMs is get relevant textual information. If I have a blog or a podcast and I want to be able to ask questions to the podcast, like ask questions about the podcast, I'll ask my question. I'll take the podcast, I'll break it up into chunks. I'll put each chunk into the vector database. When I ask my question, I can use the vector database to retrieve relevant chunks to my query. So in a sense, it's almost like a search engine. Like you're just using it to get search relevant content to your query. And we use embeddings to do that. Embeddings are just representations of text or images or anything really that they have the property where similar things are close together, but really what that allows for is just search. So RAG is search. So we have all this new stuff, right? We have RAG, we have fine tuning, we have embeddings. Embeddings aren't like super new, but they've definitely become much more popular with LLMs. All this new stuff happening, right? So the question then becomes, well, surely this is completely different, right? Like this is a whole new paradigm. And people, especially when you see agent-based models where you have multiple kind of questions being asked to different LLMs or different fine-tuned LLMs or just the same, whatever. It starts to look possible to build models without using traditional machine learning, random forest, etc. I don't think it's the case. I believe so. I remember when deep learning became everyone started talking about it. So it's probably like 2016, 2017. It's like BERT became a thing. There's all this new stuff like NLP completely changed because of deep learning. In fact, most of the ways we used to do NLP are now completely dated and no one would do in production nowadays. Now, people said that deep learning is going, that's it. Like we're just all the other, types of models no longer need to exist. We just need to do deep learning. We don't even need to do feature engineering anymore. The model will just figure it out. I think we can say now pretty clearly that that didn't happen. And before deep learning became super popular, the most common type of model was some form of a random forest, a boost, it could be like XGBoost, whatever, some type of model like that was the most popular model in production. Uh, I I would I'm almost positive in 5 years that will still be the case, but the most common model in production will still be a random forest. That said, obviously LLMs are a complete paradigm shift. It's a game changer, and it's something that I believe that companies need to be doing in where it makes sense to drive value. I also think that it's important to note that I've seen a lot of situations where people will use traditional machine learning models to build features that then feed into LLMs and vice versa, where they will, for example, like let me give you an example there. Like you might have a model that generates a credit score, but then you give that credit score to an LLM to have it generate a response. The other thing that I've seen a lot of is actually using LLMs to generate a response and then using traditional machine learning to either validate that response or even using the generation as an input to a traditional model. So I think that these things are much more tied together than people give credit for. It's definitely a paradigm shift, but it's not black and white. I think in practice, like shows that, we're kind of using old tools and new tools together to build something even better with a combination of the two. So my hot take, I don't know if it's even a hot take anymore, but I believe that MLOps and LLMOps merge because it actually looks really similar. So we've gone through this whole platform thing, right? Let's forget traditional ML and think about this from the perspective of LLMs. So on the far left, we have the data piece. Well, unless you're doing zero-shot LLMs where you don't give it any data at all, whether you're fine-tuning or you're doing RAG, a lot of what you're doing is very similar. You're taking data, you are cleaning it, you're transforming it, you are maybe A/B testing different types of data pipelines before feeding it into your model. There's model experimentation and training. Fine tuning and training look awfully similar. You don't have to fine tune. So obviously in like a traditional machine learning, like this was a key step was training and hyperparameter tuning. I think it's something that is maybe with today's environment less important. But I think that in the future, most LLMs in production will be fine-tuned as well as use RAG. And so we've already seen tools come out. In fact, like even OpenAI released a tool where you can manage your different GPTs, right? So you're training different GPTs and you're managing them. It looks kind of like MLflow, but for LLMs. Orchestration and serving. Again, if you're using GPT or if you're using OpenAI's APIs directly, then they're serving it for you. But if you're using any of the open source models, Llama, Mistral, whatever, serving is really hard. Those are really big models. And I actually think that given OpenAI, their response times can be problematic. Sometimes they go down. A lot of people, I've seen a lot of big companies are much more focused on serving their own models of Llama or whatever else so that they have full control over their latency and their uptime. And then there's monitoring and evaluation, like Langsmith from LangChain is a good example of this. There's a lot of companies that are focused on evaluation and monitoring. It's similar, right? It's like hallucination. But it's funny because hallucination is just a model over indexing on data or just dealing with data it's never seen before and just making a prediction of what it sees. Now, the problem with LLMs is that they can sometimes do something that sounds reasonable. They're trying to always sound reasonable, even though they are factually wrong. So my take is that there's a generalized MLOps platform which solves both problems. I've already seen people using features and things like feature form to serve to LLM pipelines. So using the exact same features that they're using for traditional machine learning also in LLMs. So I think that MLOps, and I think the final thing, which we've already seen at a lot of big companies, is as they're investing in LLMs, one of the key things that they're investing in is data. We need to, I mean, it's the same problem we've had for decades now. Like, how do we make our data cleaner? How do we, keep track of it? How do we decide what to use and where to use it? How do we make it searchable? Um, so my sense of where MLOps is going and LLM ops is going is it's the same. Like, I think an MLOps platform and LLM ops platform, they will generalize to become something. It's just a model platform. It's just something beyond specific types of models. Um, and I think that's the future. I think actually, like, it's almost like computer vision versus I guess non-computer vision use cases. Like, in practice, the MLOps platforms that people had for computer vision and what was important there were almost completely different from the platforms that people would have for recommender systems. But a lot of times the company or the teams building those platforms are the same team, even though the platforms they were building look completely different. And I think there's a lot of focus on, hey, where are the key pieces that are the same that we can generalize and use in both places? And I think LLMs are just a different way to utilize your data. The same way machine learning is a way to utilize your data, the same way that BI was just a way to utilize your data. LLMs are just a much more powerful tool in our toolkit to make our data more powerful. So that's all I have for you all today. And yeah, I'm open. If anyone has a lot of information, we have 5 minutes left. If anyone has any questions, I'd be happy to answer them. Again, if you're on LinkedIn or Twitter, you can throw them in the Q&A. And if you are on uh, 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 Zoom, you can just put it in the Q&A. And then, yeah, LinkedIn and Twitter, you can just post a comment. Give it a few minutes. But if you have to drop out and you're not as interested in the Q&A, that's kind of all the content I have. But yeah, if you have any questions, now would be the right time to ask. Oh, I should also add, since people are dropping off, that we'll be sending a follow-up email. I also plan to do another webinar soon. We have one next week, which will be about MLOps and fintech. I plan to do another one soon, which will be much deeper on LLMs and RAG, which will be kind of almost an extension of this one. And if you have any specific topics you have in mind or you'd like me to talk about, always glad to get uh, insights. Cool. So I'm gonna ask 2 questions. How about model retraining? And then how do you choose the right company? As there are plenty, but very few working on actual tasks of MLOps. Um, choose the right company. So I'll answer model retraining. I'd love, as I'm answering that, if you could clarify what you mean by second questions. When you say choose the right company, you mean like the right company to work for or the right tool to use, like an MLOps company to buy, or the right company to work for? I just want to make sure I'm answering the right question. So when it comes to model retraining, um, sorry, Mary, can you make me host again? So when it comes to model retraining, um, so I showed you that there are these slices, right? Like the data slice, the experimentation slice, the deployment slice, and the monitoring and evaluation slice. I was kind of generic about that platform layer. One value of the platform layer is to abstract away the fact that these 4 things are different. Another value is it allows for cross-section automation. So it's not just streamlining, it's also automation. Like, if we go back to our initial definition. And what that means, so the evaluation piece, right? The evaluation piece in the monitoring service, that's where you would get the insights of, hey, maybe we should trigger a retrain. Our model is starting to misbehave, et cetera. It could also be on the feature stores side, where you can see that your features are starting to drift. And that might trigger you to maybe preemptively retrain your model just so that you could preemptively catch problems that arise. Now, if I'm a data scientist and I'm working in a company that has all these 4 pieces, I might in my evaluation framework see that, hey, I'm seeing signs that it's time for a retrain. Then I switch to my, experiment orchestration manager. I maybe rerun an experiment that has the same model or create the same model. Then I go back to my deployment orchestration. I've then deployed a new model, and then I evaluate it and see if it is now behaving correctly. So I would jump between three different tools and back, or four different tools even at back. By having the platform layer, one, it might make it easier to jump between those tools, and two is you can create automation. You can say, hey, when this metric and evaluation goes here, it just automatically trigger a retrain, and then automatically, so maybe it's automatically rebuild my training set in the feature stage, automatically retrain that model, automatically create maybe a canary deployment of that model, evaluate it, see how it's doing, then decide how to grow it. So that would be like the kind of gold standard of MLOps, where every time something happens that can be automatically solved, it should just be automatically solved. Otherwise, it at least makes it easier to jump between things and streamline understanding what's going on and solving problems that do happen. The gold standard of MLOps is really just, hey, like here's a problem, or or it's either I'm a data scientist, I have an idea. I can go from idea to production as quick, or idea to that idea wasn't a good idea as quickly as possible. Um, and then two is hey, something's wrong. How do I solve it really, really quickly? And those are two kind of Dora metrics that I shared. Um, so the second question, what's the right company to work for? It's a really good question. I would, I think when I'm just trying to think of like companies that I've seen really, I think there's a few things that are important in like deciding which company you work for MLOps. I think if we go back to this slide, one is you want to work for a company where MLOps is really important and is like invested in. Now, ways that can happen is uh, you just look at the ML team and what they're doing, and are they actually driving real business value? If so, then they'll be investing heavily in the ML teams. One, sometimes you can just tell, or it's kind of obvious, like Spotify. Other times you might be able to tell just by looking at how many data scientists work at that company, looking at their engineering blog and seeing what they're writing about for machine learning. I think step one is find a company where ML actually matters. If ML doesn't matter to the company, it doesn't matter. The MLOps team is just not going to be as invested upon. And it shouldn't be, right? It doesn't really make sense to invest in an MLOps team if ML doesn't matter for your company. So that's, I think, the most important piece. The second piece, I think, is looking at their engineering blog, looking at how they think about MLOps, maybe seeing their talks at conferences. That sort of thing can help you understand and see how they think about it and how cutting edge they are. Um, Maybe even just reaching out to people who work there, talking to them. It can be a little hard to see externally like that unless they have a good engineering blog. But yeah, I think if those are probably, if I was looking for a company to work for, I would look at those two things to understand where I should work. That's a really good question. Awesome. We are at time. I can stay for a couple more minutes in case there are any last questions. Otherwise, I want to make sure that, you all might have other meetings you need to jump to. Cool. I'm gonna make you host, Mary, and yeah, we'll be reaching out. If you have any more questions, I'm easy to find. I'm just in that feature form. You can also come and join our feature form community, which Marie will share in a follow post. And yeah, you can reach out there.
Awesome. And yeah, for those of you who have attended, I will also be sending you kind of a post webinar email with the recording. And like Simba said, links to our docs, links to our feature form community to continue the conversation. Alrighty. Have a good rest of your day, everyone.